Okay, so if I give you a set of equations like this, what's it missing to make it really be parametric equations? It's a domain. Very good. And the domain for parametric equations would be based on which letter defaults to that. T. And T has to be, well, there's a lot of things. You could say it's like between 0 and 2. That's a real common kind of domain. Or we could say greater than 5, for example. All right, so let's say that we do a more normal one where T is between 0 and 2. And if you were going to graph it, you'd want to use an XY chart, but there's a little modification. It's actually a what? TXY chart. Could you then use something from that to get a different kind of domain? Yeah, that's the kind where if you had solved this and solved this for T, and then plugged them into each other, we can get rid of the T. We can make this all into one equation, which is kind of cool, except it's not as good because it's got only X's and Y's in it. And then what's its main issue? Why does it have problems? Why does that equation not as good as the first one? I got it down to like 3x plus 4 equals y squared plus 7, or whatever we get it solved down to. What's wrong with it now? It's lost its T. It doesn't have any time. So if I only had that, I would also have trouble because it's not going to have any stop to it. Remember, this one only went between 0 and 2, so it had a limit on each end. All right. So then what would this need? It would need an X limit. Like X needed to be between something and something. And you get that off your TXY chart. All right, next, I gave you a new kind the other day where we said, here's a point, and it's at 1, 12. And now we want to go to this other point, which is going to be at 7, 17. I need to tell you the start and the end. Let's say it starts here. And then you should be able to write me a parametric. But here's the thing. It's got to have a T limit. But you actually get to pick that. I'm just going to suggest your life will be easiest if you always pick your start at time equals 0. We've done that all the way since last year. Usually we use default to 0 as our time for starting things. And then time at the end, it's really the simplest if you just make t equal to 1. 1 second later, they're here. You get to pick that, though. But I recommend 0 and 1 because it makes your life easier. Then, once again, we write a little equation, and it could be like 6t minus 4, and this is like 5t plus 11 or whatever. And then I have to say my domain, which would be based on t, right? And t is between this and this. All right, I've just totally made up that stuff. You should find the actual answer for that directed line segment. I'm suggesting you use t equals 0 and t equals 1. I'm going to put you in groups, and you're going to work on some tough ones. These are the toughest of them today, and then tomorrow's a review, and then you take the test on Friday. Okay? So you're going to want a partner. Unfreezing my board here. Okay. Sorry about that. I'm going to pause for a second. All right. This shouldn't be super tough because this is supposed to be the easy stuff of the unit. Let's see. Row 1, person 4. That's you. Tell me what you got for your equations. 6t plus 1. And the other one? I was talking when you were saying it. So what? 5t plus 12. Are you confident? Okay. And how would you know if you were going to say, well, here's how I know it works? You plug in what point? See if 1 and 7 go in here. If I put in a 1 for time, wait a minute. You don't really put in that 1 and that 7. So which 1 and which 7? What are you talking about? T equals 0. All right. So if I put in a t equals 0 right here, I'm supposed to get what? 1. Good. And you do. So that worked. And then on the other one, you could put in t equals 1. And then you would supposed to get 7. 6 plus 1 makes 7. Cool. You can know you're right. Raise your hand if you guys had these two answers. Okay, good. Then what's it missing? Domain. And so if you didn't write the domain, you just lost the whole thing. Because parametrics are really picky about that. Have to have a domain. T has to be between, well, sometimes it's just T is greater than 6 or whatever. But in this case, why doesn't it continue? Because this is a line segment. It stops here and it stops there. It doesn't keep going. If you didn't have a limit, if you didn't do this thing, then your parametric would keep going. And we want it to only go between t equals 0 and t equals 1. Could you have made a much more complicated equation and started with t equals 18 and ended with t equals 19? You could have. But why do that to yourself? Okay. Next. I want to go with a simple parametric. X is t. Ooh, doesn't get much simpler than that. And y is t squared. And I want you to convert this from a parametric, which has a limit. We're just going to say t is between 0 and 2. And I want you to convert it over so that it's one of those other kind, a function. Also needs a domain. You don't have to graph this, but there are some elements of the TXY chart that can be helpful. All right, so just convert this. Make it into a function. I want to pause for a second while you do. All right, so TXY. Why are you doing the TXY, Mr. Server? You didn't say you had to graph it. Because I like to use it to find the domain. All right, and if I was going between 0 and 2, I might as well just do 1 along the way. 0, 1, and 2. If I put in a 0, I get 0, and 0 is 0, 0. Cool. If I put in a 1, I got a, hold on, I'm making it a little bit messy there, 0, 0. If I put in a 1, I get a 1 here, and I have x equals 1, and I get a 1 squared is 1, and then I have a 2. 2 goes in here, it's 2, and 2 goes in here, and I get 2 squared is 4. Okay, cool. Now, again, I'm all set for graphing it if I wanted to. And then, over here, I'm solving for t. It is solved for t. I'm solving for t. Well, it's not solved for t. I get the square root of y equals absolute value of t. How many remembered the absolute value? Okay, awesome. That gives you 2 answers. This is a big deal. Because then, either t equals square root of y, or t equals the opposite of the square root of y. And now this has to be put into both of them. So x equals t goes in here, you put in an x, you put in an x, and is that what I'm supposed to do? Isn't t equal to x? And then, hey, I've got 2 equations for my answer. Wasn't I supposed to just get 1 equation? Well, sometimes you can't. Sometimes you have to get 2 equations. But at least they only have x and y in them, right? Can you tell they aren't parametric? Yeah, because they don't have t's in them anymore. Okay. Now, could I solve this thing for y? Yep. And it would be good if you did. So if I solve this for y, I'm going to have y, I'm going to square both sides, equals x squared. And I'm going to square both sides of this one. Now, I got to be careful. Squaring both sides on this one is going to make that negative disappear. And then I'm going to have y equals x squared again. What? Is that right? Okay. So apparently it's just y equals x squared. And then I've got a limiter between, it used to be 0 and 2, but now it's 0 and 2. Ooh, that's weird. So x is just between 0 and 2. Now I want to actually look at what this is. I want to graph it. Because I know what y equals x squared looks like. Y equals x squared looks like this. And it just goes between 0 and 2, though. Well, that means I don't have the whole thing. I just have from 0 to 2, or x is 2 here and x is 0 here, and it's just that little part of the parabola. Could that be right? Looks like it's right. Well, let's see if the other one actually looks like this when you graph it. Let's actually use the graphing calculator. We finally are going to go into parametric mode and graph this puppy and see if it actually looks right. I'm going to pause for a second. We'll pull up the calculator and get it in parametric mode. So everybody hit the mode button. We're going to go where you have never gone before, probably. Parametric mode. So I'm going to go down here into function mode. That's normal. We were just left polar, so you're probably in polar mode. Sequence mode, that was where you do that weird u sub n equals u sub n minus 1 stuff. Probably only did it once in higher algebra. That is a topic on the ACT, but it's obscure enough that like it would take too long to teach you, reteach you sequence mode just for the ACT. But anyway, parametrics, hit enter. And then how can I tell if I'm in parametrics? Go to the y equals screen, and it looks different than before. It doesn't just say y equals, right? It says x equals this and y equals that. And then what do you think your calculator is going to default to for a variable in here? T, exactly. Look on that key that we usually hit for x. You see how it's got x, t, theta, and n? Finally time to use t. Yes, sir. I'm going to pause for a second. All right, so let's put this puppy in. X equals t. Enter. You notice it uses a capital T. It's okay. Doesn't really change much. And then t squared. So I'm going to go with t, and then I'm going to square it. Enter. Now, I don't see, Mr. Server, you made such a big deal about how you always have to have, the parametric has to have a limit. Like it's got to have a domain. Where do you think that might be? I don't see it anywhere on the screen. So, hint, it's not on the screen. Where do you think it might be? Window. Everybody hit window button. In window, I see Tmin and Tmax. Ooh, that sounds like a limit. Why do you think it defaults to 6.28? Think about it. That's 2 pi, isn't it? Aha. 6.28 is 2 pi. All right, so the calculator goes from 0 to 6.28, which means 0 to 2 pi. Does that make sense? All right, could we limit it differently than that? Sure we can. Remember that your calculator is assuming for a moment that you might want to use like sine and cosine and stuff, and then the t would be the angle, right? In our problem, we're not doing that, so we could set this to window to be anything we want, and we said, what? Between, what does it say over here? Between 0 and 2. So let's make it 0 and 2. Change that to 2. What the heck is this step thing? That's how far it's going to move before it prints the next answer. Let's talk about what I mean by that. So let's say that you were doing, thank you, a problem in polar. Do you remember it before in polar? It would give you an answer, and then it would like move an angle a little bit, and then it would give you another answer, and then it would go a little further, and then it would give you another answer, and those are called the steps. Okay, it's like that. So how am I going to change this step? Well, first of all, 0.13 is not just a random thing. It's based on pi. And I think it's like pi divided by 12, like a 12th of a pi or something like that. Can anybody verify that? You take the pi button and say divided by 12. It's pi divided by something is 0.13. Not sure exactly if it's like 16ths of a pi or something. Anyway, we can make the steps anything we want. Okay? So let's just play around with it and see what happens if we use steps of 0.1. Use steps of 0.1. Now, what is this x min and x max? Well, there are x and y variables, right? Remember when we graphed stuff before, we could set that to be either a really small window and you only see part of the graph, or really big so you can see like, you know, from 0 to 100 or whatever. We can set those to whatever we want. All right, so let's make our x min 0 and our x max 15. And then to scale, always count by ones. X min 0 till, let's say, 15 again. Okay, now it's time for the big reveal. Hit graph. Does it look like still part of a parabola? Is that kind of what we expected it to look like? Okay, now, what if we didn't do as big as steps? What if we did bigger steps? Let's see if it makes any difference in how this thing looks. Okay, so I'm going to go back to my window and make my steps be big, like 2. What? It straightened it out. It still connected the dots, but it didn't have anything in between. Remember me saying it was going to like go out and then do one and then go out and then do one and go out and do one and go out and do one, and then eventually it would have done a whole bunch of steps. It would give you a whole bunch of points in between. So basically, if you want a more accurate graph, do lots of steps, because it'll like show you everything in between. Okay. All right, so I'm going to go to Window, and I'm going to say I like my 0.1 better. In fact, maybe I should do even more steps. Maybe I should go 0.01. Every 100th of a, in this case, second, because t is time in our case. Could have been angle, too. It's going to do one. Now, let's see if that makes the graph look any different. It just graphed more points. So I don't know if you noticed it went slower. But it still kind of looks like the parabola we wanted in the first place. So do you get that 0.1 or 0.01 would have been just as good? Really wouldn't matter. What if I make steps equal to 1? Put a window, step, 1 hole. That's going to be a lot less steps, a lot less points graphed. I hit graph. You get how it got kind of like a parabola, but kind of clunky? Because it didn't graph as many points. It only went over 1. It did 1 for here, and then it did 1 for here, and then it did 1 for there. And it only basically had 3 points, and it connected the dots. So it looks kind of squarish. So moral of the story, make the steps small, and you'll see a more accurate graph. All right, so in our case, back to the window, I'm going to settle on a step of 0.1. I think that was fine. 0.01 would be even better, but make your steps really small if you want to see a really accurate graph. All right, so I'm going to go to, not second graph, sorry, how do we get unsecond? I'll just quit. And then I go back to this, and then I go to graph. Okay. So now let's play around with some kind of cool ones, just for a little bit. Let's try to find some kind of cool graphs. You remember before we could make those cool kind of spirally things and stuff? All right, let's see what cool things we can graph with parametrics. I'm going to pause while we find some slides like that. This is on the slide we've been in for a couple of days now, and I think it's like slide 3 or 4. Can anybody verify from the kids' perspective what slide number this is? 4th one, thank you. It's got negative 0.1 t squared plus 3. And for the y, it's got t minus 5. Notice it says t max 10 and t step 0.1. All right, it also says here's a bunch of stuff to use for mins and maxes and stuff. Once again, I'd like you to end up being able to play with this, try to find some cool ones that you create. But for right now, everybody just type in this one, please. I'm going to pause for a minute while we get that typed in into our parametric graph equations. Okay, I somehow squared my 5. I'm going to get rid of that. I'll try that again. T minus 5. Okay, there, I've got the first part entered. Now, how am I going to enter this T max and the T step? I'm going to go over to Window. And it says T min. It doesn't tell me any T min. I'll leave it default to 0. That's okay. T max 10. T-step says 0.1, so we got 0.1, so we're good there. X min, it says use -10. If you aren't changing these numbers, you're not going to see as cool a result. X max, 10. Y min, -10. Y max, 10. And then hit graph. Not exactly earth-shaking. Would you ask me a question? I couldn't tell. Okay. All right. Okay. Now, let's mess with some things. Instead of having a T-step of 0.1 and a T-max of 10, try playing with those numbers and see if you can make the same graph look different. And pause for a second. Okay, I wasn't able to find anything really cool with just playing around with the T-step. The only thing that, if I change the T-step to be really big, then I don't have many steps between when it goes out and makes its points. And so it gets more clunky. I could make it look a little more blocky, but nothing really particularly cool. Did anybody figure out a way to make this one look particularly cool? All right, then we're going to move on to one that definitely looks particularly cool. Go one slide past here and type this one in. I think you're going to like it. I'm going to pause for a second while we put this one in the calculator. Okay, so for this one, when I put in a 2 for this spot right here, I tried a 2 in there and I got this. I thought it was kind of cool looking. All right, so what if I just play with it a little bit more? Try like a 5 or something there. Well, that's pretty cool. All right. Now, that's obviously just messing around with sine for one of them and cosine for the other one. And there's all kinds of possibilities. Okay. Does anybody find anything that was particularly cool? Don't be shy. Raise your hand. Tell me something. I'll put it in. I'll put it in and see what it looks like for the class. What'd you get? Yep. Ooh, pi. I like it. So I'm going to go back here. I'm going to make it pi t. I like that creativity. All right, so I'm going to make that a pi. I'm going to hit graph. Ooh, and it's still going. Oh, and what if I wanted it to keep going? Because it looked like it was on a roll and I'm going to make something kind of cool. I'm going to go to my window, and I only let it go until T-max of 10. What if I let it go to like 100? Play with my T-max and let it go further, because it seemed like it wanted to keep going. Then I'm going to hit graph and see what happens. Ah, that's awesome. It's like a little spiral. Now it's blocking in, and it's going to... It's like chainmail or something. It's still going. Okay, awesome. Thank you. I'm gonna, if you want to stop your calculator because it's like, okay, this is going to take forever. If you hit the on button, it does what called breaks it. It doesn't really break it. It just breaks the sequence. And then you can get back out. Okay. So what is the keys here? To make something cool here, use sine and cosine. And then mess with your window. And in the window, mess with your T-max and your T-step. Okay? If I make my T-step different, like 2 or something, and then graph it, it's going to look totally different. Whoa. It just disappeared. It's like a completely different graph. So if I make my T-step be like 0.001, Oh, it doesn't like that. I broke it. All right. Okay, so at least you know how to put in a graph on a calculator. Here is a typical question off the test. Okay. How would we ask you to graph one? We might say x is cosine squared of 2 theta, and y is sine squared of 2 theta. And I want you to graph this between 0 and pi. Why are my t's angles now? Because you're doing cosine of them. They got to be an angle, right? Your calculator will default then to being in radians when you do something like this. Imagine you had to graph this. Go ahead. I bet you know everything you need to know to be able to do this. I told you the t numbers. The only thing I can think it might be tricky for you is trying to figure out where to put that whole t limitation. I'm going to pause for a second while you try to put that in the calc. All right, one more thing to tell you about. This is a common type of question where they set just x equal to t. If x equals t, then t and x are the same thing, right? And it says x equals t, right? So then isn't this equation then, right here, the same exact thing as y equals t squared plus 2t plus 1? I mean, if x really is t, then isn't this the same thing as this? Okay. So then, do you get what I just did? Is I started with something that wasn't parametric. See, that wasn't parametric. Y equals x to the 5th plus 2x plus 1. That's not parametric. And all of a sudden, look at this. By just substituting in x is t, I turned it into a parametric. We had practiced taking parametrics and making them into rectangular. Now you can take rectangular and turn them into parametrics. How? By just saying x equals t. So let's take a really simple one. Y equals x squared plus 7. You know what that looks like. It's a parabola shifted up 7, right? What if you want to make it into a parametric? Just say, well, I'm going to say x equals t, and then you need another equation, right? Y equals something with t in it, and since x equals t, see how easy this is? All of a sudden, this is just t squared plus 7. Do I have a parametric? Yeah. The only thing I don't have is my domain. And so when this says x equals 1 to x equals 1.4, that's telling you the domain in terms of x. Then you just have to change that domain over to in terms of t. It's that simple. So if I started with this, you could say, okay, well, if I want to make a parametric, I need a y equation and an x equation. And you just start by saying x equals t. And if x equals t, just put a t in here and you got your y equals equation. And then the only thing left that I'll teach you more about tomorrow is then how do you do your domain? T has to be between something, and hint, it comes from the xy chart, or the txy chart. Just got to figure out what t is at those different values of x. All right, I'll teach you more about that tomorrow. All right, now, stop. Don't move, please. Don't move yet. All right, so you remember yesterday I assigned doing these first couple directed line segments, that one and this one, okay? I'm going to just have you do one more of those directed line segments like that. So just adding on to yesterday's homework, one more problem like that. And I believe, which one of these did you do before, 19 or 20? I don't remember. What? Neither one? Then we'll just add those two, 19 and 20. Okay? Okay, that's all I got for you for today.